welcome. In this video, I have selected question number 4 of the exercise for freshman mathematics on page 19, question number 4. Previously, I have solved question number 2. And this question is about an open proposition. The question is to determine whether the statements are true or false. An open proposition n given by 5 times n minus 6 divided by 3 is. So to answer this question properly, you need to remember two things. Okay, what is an integer and what is not an integer. So the question is to determine with explanations whether the following statements are true or not. For all n an element of z, p of n is part A. This will be false. This will be false if you can find just one faulty counter example. One example, let's say n not from an integer element of z, result p of n not is false. And example ፈልጋችሁ p of n false የሚያደርገው ያ ማለት p of n not will be 5 times n not minus 6 divided by 3 is not an integer. ከሆነ then for all n, okay, an element of z p of n is false. This is called proof by counter example. And የዚህን statement proposition and example ማሟላ example ካለ for all n an element of p of n will be false. But for the existential quantifier, there exists n an element of z p of n ማለት ይሄ true የሚሆነው በተቃራኒው ይሄ true የሚሆነው አንድ example ካገኛችሁና ይሄንን statement true የሚያደርግ ማለት ነው. We can find a single example which satisfies this statement, then we can say that there exists an element of z p of n is true. That means if one can find a single integer result p of n is true, then you can say there exists an element of z p of n is true. የሁለቱ ልዩነት ማየት አለበት። የመጀመሪያው ዩኒቨርሳል ኳንቲፋየር ነው። ዩኒቨርሳል ኳንቲፋየር ፎልስ የሚሆነው ከተሰጠን ዶሜን ውስጥ አንድ ኤግዛምፕል አግኝተን አንድ ኤግዛምፕል ስቴትመንቱን ፎልስ የሚያደርግ ኤግዛምፕል ካገኘን ዩኒቨርሳል ኳንቲፋየር ጠቅላላ ፎልስ ይሆናል ማለት ነው። On the other hand, existential quantifier will be true if you can find a single example which can make the proposition true. ለምሳሌ take n not to be 6, p of 6 ስንት ነው? p of n equals to p of 6 result 5 times 6 minus 6 divided by 3. So this means p of 6 is 6 in common supposed to this means this is 8 is an. There exists n an element of z p of n ማለት there is some number which can make the given open proposition true. ይሄ ግን for all n p of n ማለት ሁሉም በተሰጠ ዶሜን ውስጥ ሁላቸውም ይሄንን ፕሮፖዚሽን ትሩ ያመጣሉ ማለት ነው። እዚህ ጋር ግን የሆነ ቁጥር እናገኛለን። ይሄ ስቴትመንት ሁሉንም ባይሆንም ማለት ነው የሆኑ ቁጥሮች እናገኛለን አንድም ቢሆን ትሩ የሚያመጣው። ስለዚህ የመጀመሪያው ፎልስ የሚሆነው ለሁሉም መስራት ስላለበት የመጀመሪያው ፎልስ የሚሆነው አንድ ኤግዛምፕል ውሸት የሚያደርገውን መፈለግ ብቻ ነው። ለዩኒቨርሳል ኳንቲፋየር አንድ ኤግዛምፕል መፈለግ ነው ውሸት የሚያደርገው። ለምሳሌ for all x an element of real number x square is greater than 0 ብትባሉ አይሆንም። ምክንያቱም x 0 ሲሆን ምን ይሆናል? ይሄ open proposition 0 square greater than 0 which is 0 greater than 0. So this is false. So it is wrong to say that every real number satisfies this open proposition. Okay, you need to find just one counter example to make the whole statement false. But in the case of existential quantifier, there exists x an element of real number, say that x is greater than 5. Yes, we can find, for example, x ስድስት ብናረግ 7 ብናረግ 8 ብናረግ ነገር ግን -1 ብናረግ -2 ብናረግ እስከ 4 ያለው ብናረግ ፎልስ ነው የሚመጣው። ግን የሆነ ይሄንን የሚያሟላ አለ የሚለውን ቼክ አድርገናል ማለት ነው። ስለዚህ this is the difference between the universal quantifier and existential quantifier. So with that we can say that for our proposition part A የተሰጠናል እዚህ ያዝነው ጥያቄ part A የሚለው for all n an element of z p of n truth value ፈልጉ የሚለው ካውንተር ኤግዛምፕል እንፈልጋለን። ለዚህ ፎልስ ነው ያደረገው። አንድ ካውንተር ኤግዛምፕል ለምሳሌ ውሰዱና you can take ሁለት መውሰድ እንችላለን። so p of 2 will be 5 times 2 minus 6 divided by 3. So p of 2 is 10 minus 6 is 4 divided by 3. This is not an integer, it is a rational number because it is the ratio of two integers. So this is a rational number, so it's not an integer. So p of 2 is false. So we have found a counter example which makes p of n false. Therefore, what is the conclusion? For all n an element of integer, p of n is false. But part B, question number 4B, there exists an integer p of n is true because there exists an element of integer p of 6 is an integer. Actually any multiples of 3 p of